Hello, in this video, let's talk about multiplication of matrices. Let us begin with scalar multiplication. Example, say we have -2 times a certain matrix. Let's say this matrix. So scalar multiplication is quite simple. Just multiply this constant value to each of the elements inside the matrix. So the result should be -2 times 4. So -2 times 4 and then -2 times 1. Make sure you take note of the location of each element. Don't get them mixed up. -2 times 2. And then -2 times -1. -2 times 0. And -2 times 7. And all we have to do is perform the multiplication. -2 times 4 is -8. -2 times 1 is -2. -2 times 2 is +4. Rather, -4. -2 times -1 is +2. -2 times 0 is 0. -2 times 7 is -14. So this is the answer. Another example. Say we have the following matrix operation. Okay, so the first step here is we will not add. Okay, of course, we have to multiply the scalar multiplication here. So multiply 4 times -2, that's -8. So we have -8. 4 times 5, that's 20. 4 times -8, that's -32. 4 times 0 is 0. Now we can actually add this to this matrix over here. So we have -3, 6, 8, and -5. Let's just add. All right, so -8 plus -3, -11. -32 plus 8, that's -24. 20 plus 6 is 26. And 0 plus -5 is -5. Therefore, this is the answer. Now, let us proceed to actual multiplication of matrices. Alright, so this is the rule for multiplying matrices. The number of columns of the first matrix should be the same as the number of rows of the second matrix. So let me show you. For example, we have matrix A, and let's say the dimension or the order is 4 by 3. And let's say we're about to multiply this matrix to matrix B. And let's say matrix B, the order is 3 by 2. Can we multiply matrices A and B? The answer is yes. Because as I've said earlier, the number of columns of the first matrix should be the same as the number of rows of the second matrix. If they are not the same, then you cannot multiply the two. Okay? And the question is, what is the order of the product? So if you multiply matrix A times matrix B, the dimension is 4 by 2. So 4 by 2. The number of rows of the first matrix and the number of columns of the second matrix. So let's have some actual example problems. Given the following matrices, find the product A times B. Okay, so we need to solve for the product matrix A times matrix B. But before solving, let's confirm first whether A and B can be multiplied to each other. So matrix A is a 2 by 2, right? So matrix A is a 2 by 2 matrix, while matrix B is also a 2 by 2, 2 rows, 2 columns. And the number of columns of the first matrix, matrix A, is the same as the number of rows of the second matrix, so this is okay. And by prediction, the product A times B should have an order of 2 by 2. So 2 by 2. So let's proceed with multiplication. All right. So this is the process. We have to multiply the first row of the first matrix, matrix A, the first row to the first column of matrix B. Okay? So how do we do that? Multiply 1 times 5 and then plus 4 times 9. All right? So 1 times 5 and then plus 4 times 9. And since we are multiplying the first row and the first column, the element should be in the first row, first column. Okay? Next, let's multiply the second row to the first column. So 3 times 5 plus negative 2 times 9. 3 times 5 plus negative 2 times 9. And since we're multiplying the second row by the first column, this element right here is the element in the second row, first column. Next, let's multiply the first row to the second column. 1 times negative 7 plus 4 times 6. Next, multiply the second row to the second column. 3 times negative 7 plus negative 2 times 6, so that's negative 12. And we just have to simplify. 1 times 5 is 5, while 9 times 4 is 36. So 5 plus 36, that's 41. Next, 3 times 5 is 15, while negative 2 times 9 is negative 18. So positive 15 minus 18, that's negative 3. Next, this is negative 7, 1 times negative 7, plus 24, 4 times 6. So negative 7 plus 24, that's 17. And lastly, 3 times negative 7, negative 21, plus negative 12, that's negative 33. And therefore, this is the answer. And as we can see, the dimension or the order of this product is a 2 by 2 matrix. So this is a 2 by 2, just like what we have predicted earlier. Next, we have the same matrices, matrix A and B, but this time we have to solve for B times A. The first one, that's A times B. Now we have to solve for B times A. So matrix B times A is equal to, you might think that A times B is equal to B times A, but let's see. So let's multiply the first row to the first column. 5 times 1. So 5 times 1 and then plus negative 7 times 3. Next, let's multiply the second row to the first column. So 9 times 1 plus 6 times 3. Next, multiply the first row to the second column. 5 times 4 plus negative 7 times negative 2. Next, the second row, multiply to the second column. 9 times 4 plus 6 times negative 2. Next, let us simplify. 5 times 1 is 5, while negative 7 plus 3 is negative 21. 5 plus negative 21, that's negative 16. 9 times 1 is 9. 6 times 3 is 18. 9 plus 18 is 27. Next, 5 times 4 is 20. Negative 7 times negative 2 is positive 14. So 14 plus 20 is 34. Next, 9 times 4 is 36, while 6 times negative 2 is negative 12. So 36 minus 12, That's 24. So this is the product B times A. And as we recall earlier, the product A times B, that's 41, -3, 17, and -33. And we can conclude that they are not the same. So A times B is not equal to B times A. So it means multiplication of matrices are not commutative. Next problem. Okay, so before we multiply this expression, let's analyze first the orders of each matrix. So for the first matrix, we have 2 rows and 3 columns. So this is a 2 by 3 matrix. While for the second matrix, we have 3 rows and 1 column. So 3 by 1. And as we can see, the number of columns of the first matrix is the same to the number of rows of the the second matrix. So we can multiply them. And the resulting product should be 2 by 1. Okay? So let's proceed to solving. Let's multiply the first row by the column. There's only one column here. So 1 times 2 plus 0 times 1 plus 2 times 0. Next, let's multiply the second row to the column. Okay, so -1 times 2 plus 3 times 1 plus 1 times 0. And let's simplify. 1 times 2, so this is 2, this is 0, and this is 0. So right here we have 2, and then -1 times 2, that's -2. 3 times 1 is 3, and this is 0. So -2 plus 3 is 1. So this is the answer. Okay, let me box. And as we can see, this matrix is indeed a 2 by 1 matrix. 2 rows and 1 column. 2 rows and 1 column, just like what we have predicted. Next, let me write the problem. Okay, before we start multiplying, let's analyze the orders. For the first matrix, we have 3 rows and 2 columns. So this is a 3 by 2 matrix. How about the second one? We have 2 rows and 2 columns. So 2 by 2. And as we can see, the number of rows, rather the number of columns of the first matrix is equal to the number of rows of the second matrix. So they can be multiplied. And the resulting matrix should be 3 by 2. All right, let's proceed to multiplication. Let's multiply the first row by the first column. So 2 times 1 plus -1 times 2. Next, 0 times 1. Multiply the second. Next, multiply the second row to the first column. 0 times 1 plus 3 times 2. 0 times 1 plus 3 times 2. And for the third row, multiply the third row to the first column. 1 times 1 plus 4 times 2. Next, going back to the first row, multiply this to the second column. So 2 times 0 plus -1 times 5. So 2 times 0 plus -1 times 5. Next, multiply the second row to the second column. 0 times 0 plus 3 times 5. 3 times 5. Next, third column multiply to the second column. Next, third row multiply to the second column. 1 times 0 plus 4 times 5. Next, let's just simplify. 2 times 1 is 2, and this is negative 2. So 2 plus negative 2, that's 0. Next, 0 times 1 is 0. 3 times 2 is 6. 1 times 1 plus 4 times 2, 8. So 1 plus 8 is 9. Next, these are all zeros. Okay? Negative 1 times 5 is negative 5. 3 times 5 is 15. 4 times 5 is 20. And as we can see, we have 3 rows and 2 columns. 3 rows, 2 columns. So this is the answer.